live classes of class 11th sponsored by Osepa. I am Sarita Mohanty, lecturer in chemistry, and today we are going to start a new topic, that is hydrocarbon. This is your unit number 13 and hydrocarbons. As you know, we have discussed briefly about hydrocarbons in the chapter number 12, that is organic chemistry, some basic concepts and techniques. And in chapter number 13, we are going to study the hydrocarbons in detail. This is some portion of the syllabus. This is some portion of the syllabus which we are going to study in the upcoming classes. That is, first we will read the classification of the hydrocarbons, then we will start reading aliphatic hydrocarbons. Under aliphatic hydrocarbons, we will read alkane, alkenes and alkynes, how they are prepared, what are their properties, physical and chemical properties, and what are aromatic hydrocarbons. In today's class, we are going to study the classification of hydrocarbons and alkanes and their methods of preparation. So, this is your syllabus for the alkane. In alkane, today we are going to cover aliphatic hydrocarbon, alkanes, nomenclature, isomerism, the methods of preparation of alkanes, that is from how alkanes are prepared from unsaturated hydrocarbons, from alkyl halides, from carboxylic acid, and physical properties, chemical reactions. This is the syllabus for alkane. Now, before starting this chapter, the first question arises, what are hydrocarbons? Hydrocarbons are simple compounds containing only carbon and hydrogen. Mane rakhta, they contain only carbon and hydrogen. Okay. So, hydrocarbons are considered to be the parent compound of the organic compound. This is the simplest one, and this is also considered to be the parent compounds. Means all other organic compounds are considered to be derived from the hydrocarbons by replacement of one or more hydrogen by any appropriate functional group. तो जेकोसी functional group it assume करा जाए जे all your organic compounds are actually being derived from hydrocarbons. केमती derive करा जाए ना by a replacement of one hydrogen of the hydrocarbon by any appropriate functional group. Now let us see why should we study hydrocarbons. Hydrocarbons are widely distributed in the nature in the form of your natural gas, petroleum and coal. The LPG gas which you are using in your kitchen for day-to-day cooking, it is what is LPG? You know, liquefied petroleum gas. This is CNG, compressed natural gas, a term sab sunithibo. So, from this you can imagine that most of our energy requirements are fulfilled by hydrocarbons in some way or other. तुम्हें गाड़ी ड्राइव करो, whether you are driving your vehicle, you are putting petrol within it, it is your hydrocarbon. The gas you are using in your kitchen, that is your also hydrocarbon. The plastic, importantly, the plastic which are using in our day-to-day life are nothing but hydrocarbons. So, from this you can imagine how much important our hydrocarbons play, how much important role the hydrocarbon play in our day-to-day life. So, for that you should understand some basic concepts regarding hydrocarbons. So, first of all, let us study the classification of hydrocarbons. How the hydrocarbons are actually classified. The hydrocarbons are basically classified as alicyclic or open chain and cyclic or closed chain. The broad classification जदि तमर hydrocarbons आसिला then it is classified into two types, that is depending upon the structure of the carbon, that is whether it is open chain, it contain open chain carbon. If it contain open chain carbon, then it is called what? Aliphatic hydrocarbon. If it contain a closed ring like structure or a cyclic structure, then it is called cyclic or closed chain hydrocarbons. Now these acyclic or open chain hydrocarbons are further divided into three types, that is alkanes, alkenes and alkynes, and we will read one by one. If there is presence of only carbon, single bond carbon, then this is called alkanes. এটা তুমি সমস্ত জানতো carbon double bond carbon, there is presence of carbon carbon double bond, then it is called alkenes, and carbon triple bond carbon, then these are called alkynes. So let us see the example of first open chain hydrocarbons. Now these are some examples of your alkanes, that is they contain only carbon carbon single bond. Mark methane, ethane, this is your propane, only carbon carbon single bonds. Okay. Now these are the basic things, that is why I am going a little bit quicker. Then these are alkenes containing carbon carbon double bond. Alkenes are compounds containing carbon carbon double bond. Mark, here is a double bond, so alkene, here is a double bond, so alkene. एगुड़ा सब तुम्हें स्कूल रो already पढ़ी आस्थिव. Then let's see what are cyclic or closed chain hydrocarbons. Hydrocarbons which contain a ring like structure are called closed chain hydrocarbons. Now these closed chain hydrocarbons are further divided into alicyclic and aromatic hydrocarbons. Now let us see what are alicyclic hydrocarbons. Now alicyclic hydrocarbon means they contain, alicyclic means they have cyclic structure, but their physical or chemical properties, in their physical or chemical properties they resemble with aliphatic compounds. माने cyclic structure थिबा सत्वे भी कहाँ से तो resemble करंती, तुम्हारा open chain compound से तो resemble करंती. So these are divided into your cycloalkanes, cycloalkynes just like this. This is your cyclopropane, this is your cyclobutane, likewise similarly cyclobutene. So though they have a ring like structure, but they resemble in their properties with that of the aliphatic compounds. Hence the name, hence the name alicyclic. Aliphatic plus cyclic, asla kon alicyclic. We have already read all these things in your chapter number 12. So mark, here is the your this is cyclopropane, this is cyclobutane, cyclohexene, etc. Now what are aromatic hydrocarbons? Now aroma, the term aroma comes from Greek word. They are having, initially when the aromatic compounds were discovered, those compounds are having very beautiful smell or fragrant smell, hence the name aroma. So total name asla kono aromatic compounds. They are special type of compound having cyclic marker, cyclic unsaturated compound, but they differ from all other organic compounds in their stability. They are very much stable because of their kono, they have a very stable structure due to their pi electrons present in them. Okay. Now the aromatic compounds are further divided into two types, that is benzenoid aromatic compounds and non-benzenoid aromatic compound. Na dekho kaun sa just kurchi, na benzenoid compounds. Benzenoid compounds, aromatic compounds means compounds which have benzene, one or more benzene like structure. Mark karo. Here this is your benzene, So, it is a benzenoid aromatic compound. It contains benzene and an amine group. Its name is aniline. So, it is also an example of benzenoid compound. Here 2 benzene rings are actually fused. This is called naphthalene. तुम जो use करचो ball गुड़ा moth ball तुम घरे use करचो. This is actually that naphthalene. Okay. So, what are non-benzenoid aromatic compounds? These are organic compounds which are aromatic but do not contain a benzene ring, but other highly unsaturated rings. Mark karo, aromatic means it does not imply it should always have a benzene ring within it. There are some compounds are there which do not have any benzene ring, but they show the property of aromaticity. For example, eutropine, mark karo. या structure रे तुम्हें लागू चेड़ा benzene भलिया no, but it is an aromatic compound. Similarly, your azulene, it भी benzene structure नहीं, but it shows the property of aromaticity. So these are special type of compounds which are highly unsaturated ring and they have aromatic properties. Now today we are going to discuss elaborately about alkanes. So, alkanes are the simplest family of hydrocarbons, because you know only there is presence of single bond between carbon, carbon, carbon single bond or carbon hydrogen single bond. Only all the valencies of the carbon are satisfied by single bonds. Hence, they are the simplest kind of compounds, organic compound. They are also called paraffins. Mark that question. It has been asked many times in the entrance examinations. Remember that alkanes are also called paraffins. Why? In Latin, param means less. Param means less. Less affinity. Actually, they are very stable. They usually do not react with your acid or base or your oxidizing agent or reducing agent. Under normal condition, they do not react with this kind of reagent. Hence, they have a less affinity towards the all the chemical reagent. Hence, the name paraffins. एटा मन रखिबो alkanes को paraffins को आजे बहुत थोड़ा exam रे आसे. However, under drastic condition, that is, if you give a very high temperature or you give some catalyst, then under that condition they will react with some reagents. Now, let us see the nomenclature. The nomenclature of alkane is quite simple and we have discussed it elaborately in your unit 12. Unit 12 रे हमें nomenclature रे पूरा detail पढ़चे. So, जो मैंने देखी ना सेटा branch chain alkane रो तारो link टा तुम्हें आउ थरे जाए कि Osepa site रे देखी परियो. So, alkanes are actually its general formula is CnH2n plus 2. एटा समझते जानी थी वो. So, its general where n stands for 1, 2, 3. So, its general formula CnH2n plus 2. Now, let us see the name for first carbon, it is methane. If it contains 2 carbon, it is ethane. For 3 carbon, the name is propane. For 4 carbon, the name is butane. All these things you have already been taught in the unit 12. So, how it is being formed? Your word root. How the alkanes are actually named? Simple alkane are named. Word root, these are the words meth, eth, prop, but. Then suffix is ane. Your word root plus ane. Suffix is actually ane. Ane symbolizes that there is presence of only carbon-carbon single bond. Remember that. So, how can we IPSC nomenclature rules for naming a branch chain alkanes? We have discussed it and you please do watch the link again. So, first you have to choose the longest carbon chain, then the carbon atoms which are not included in the parent chain are considered as substituent. We have already discussed all these things. Okay. Now, you have to the rules for larger number of side chains. If you have 2 options, how to choose a long chain? Always choose the long chain which will give you more number of substituents. Then lowest set of locant rule, that is you should start numbering from the carbon end, so that the substituent will get the lowest possible number. Then the name of the branch chain, how it is being named? Now prefix the substituent. The substituent is always prefixed before the word root and separated from the locant by a hyphen. And if more than one substituent is present, you should name them alphabetically. ये सबुतक thing, सबुतक जिनसा rules सबुतक in detail तुमको पढ़ाई ची unit 12 रे. So I am just having I am just going through this all things very quickly. Now this is important, that is types of carbon and hydrogen atoms in alkanes. If in alkane, if the carbon is attached to only one carbon atom or only hydrogen, then it is called primary carbon. If the carbon is attached to two other carbon atoms, it is called secondary carbon. And if the carbon is attached to three other carbon atoms, it is called tertiary carbon. Carbon attached to four other carbon atoms are called quaternary carbons. So mark karo. This is an example. In this example, mark this one. This carbon is actually attached to 1, 2, 3, 4 other carbons. Hence, it is an example of quaternary. आमे primary, secondary, tertiary को केन देखाओ 1 ऊपर degree. Similarly, mark this carbon atom. This carbon is directly attached to another carbon, only one carbon. Hence, primary. This carbon is attached to two other carbon atoms. Mark karo. This one is attached to two other carbon atoms, hence secondary, and this carbon atom is actually attached to 1, 2 and 3 other carbon atoms, hence tertiary. Why you should remember what is primary, secondary and tertiary? Because gradually you will see that the hydrogen attached to primary, secondary, tertiary, or the functional group which is attached to primary, secondary and tertiary carbon will behave differently. तुम्हें reaction देखाओ, तुम्हें same reagent दबा, but primary, secondary, tertiary carbon will behave differently. So you should learn this concept very thoroughly. Easy concept. Now isomerism in alkanes. So what are isomers? Now molecular formula representing same molecular formula. They will two compounds, they will have the same molecular formula, but they will represent different structures. Alga structure, pura alga molecule, same molecular formula representing different structures of the molecules are called isomers, and the phenomenon is called isomerism. So alkanes, they show chain isomerism. Alkanes show only one type of isomerism, that is chain isomerism. So what is chain isomerism? Now compounds which have same molecular formula but they differ in the arrangement of the carbon chain within them are called chain isomers. Example देखिए clear होगा? For example, mark. The formula is C4H10. Here the formula is also C4H10. Hello. Here also the formula is C4H10, but mark that here the parent chain, the length of the parent chain is 4 carbon, but here the length of the parent chain is only 3 carbon. Name of this compound is butane, while name of this compound is 2-methyl propane or isobutane. Mark karo. From your fourth carbon onwards, or alkanes having 4 carbon. From that onwards, they will show chain isomerism. Your alkane having 1 carbon, 2 carbon and 3 carbon, they do not show any kind of chain isomerism. Why? Because it is not possible to arrange the carbon atoms or the alkanes having 3 carbon atoms in any other way. तुम्हें केवल तो गोटे स्ट्रेट लाइन नहीं लिखि परिबो आ को उपाय रे भी लिखि परिबो नहीं. So up to propane they don't show chain isomerism, but from butane onwards they show isomerism. And mark that with increase in the number of carbon atoms, your number of chain isomers will increase. So, this is an example of pentane. Now, the formula is same for everything. All these structures have the same molecular formula, that is C5H12. But here the main chain it contains 5 carbon atoms, while this chain contains 4 carbon atoms, and this compound contains 3 carbon atoms. So, the name of the compound is pentane. Its name is what? Isopentane. Its name is neopentane. So, these are actually 3 different compounds, they are not same compounds. Mark karo, butane ne kon hotla dita isomer dekhotla, but pentane gala balku tinta isomer hegala. Similarly, in case of hexane, we have 1, 2, 3, 4 number of isomers. As I have already told you, with increase in the number of carbon atoms, the chain isomers number also increases, because then you have many options to arrange the carbon atoms in different ways. Now, let us see, that is the methods of preparation. The methods of preparation of alkane. The first method of preparation is from unsaturated hydrocarbons. What are unsaturated hydrocarbons? Hydrocarbons having double bond or triple bond are called unsaturated hydrocarbons. So, first of all we will learn that how you can prepare alkane from alkenes and alkynes. Dekhiba kemti prepare kariba. So, mark karo. So, here there is presence of C double bond C. Now, I want to convert it to C single bond C. So, mark karo, there is only what happening here, now only the pi bond is getting converted into sigma bond, with hydrogen atoms are being incorporated into the molecules. So, what will be the reaction? Now, the reaction will be your addition of hydrogen. So, alkene and alkynes, they add 1 or 2 moles of hydrogen respectively to give you what? Alkanes. Now, this reaction is actually carried out in presence of a catalyst, that is it may be nickel or palladium or platinum. So, remember that addition of hydrogen, whenever in organic chemistry you will learn the word or you will hear the word hydrogenation. Hydrogenation means addition of hydrogen. Remember this term, very important. Addition of hydrogen is called hydrogenation. So, here the catalyst used are ranitidine, platinum or palladium. These are the catalysts which are used. Mark that if you use ranitidine, platinum or palladium, this reaction will take place at room temperature. But if you use only nickel, then you have to supply high temperature, that is 200 to 300 degrees Celsius. Why this is happening? Because in ranitidine, the surface area of nickel has been increased. What is ranitidine? Ranitidine is an alloy of nickel and aluminum. Actually, this is an alloy of nickel and aluminum. Alloy school lu padi ascha. Alloy kon dita metal ku fuse kari kara jaye. So, it has been formed by the fusion of nickel and aluminum. Now, sodium hydroxide is poured into it. You know that sodium hydroxide dissolves aluminum. So, it will react with aluminum and it will left the alloy. So, tadare pore rahegala ki nahi. As a result of which the surface area of the nickel will increase. That is called ranitidine. So, mark here your ranitidine, platinum or palladium, 1 mole of hydrogen is being added to the alkene forming alkane. Similarly, for alkynes 2 moles of hydrogen are actually being added forming alkane. Remember that if ordinary nickel is used, then you have to, I have already told you, if you use ordinary nickel, you have to supply high amount of energy, and that reaction is called Sabatier-Sandrin reaction. I think this is the first named reaction which you are learning in chemistry for in your class 11th. This is called Sabatier-Sandrin reaction. Remember students, do remember all the named reactions. Named reaction maximum time entrance ho ki board exam ho, named reaction guda pachara jaye. So do remember the names of this reaction, that is Sabatier-Sandrin reaction. Alkenes or alkynes react with hydrogen in presence of nickel catalyst, temperature 200 to 300 degree Celsius to give you alkenes. This is actually called, this type of reactions are actually called catalytic hydrogenation. Catalytic hydrogenation. Addition of hydrogen is called hydrogenation. There is presence of catalyst, hence the name catalytic hydrogenation. Mark that here the addition of hydrogen actually takes, this is the syn addition. Remember, it entrance both this is syn addition. Whenever the hydrogen gets added to the alkene or alkyne, what is a syn addition? If the hydrogen gets added to the same side, then it is called syn addition. So here what happens? Now here the hydrogen is getting added to the same side, whether to this side or to this side, but the hydrogen will remain in the same side of the molecule. This is called syn addition, very important for entrance. Now the second named reaction is Wurtz reaction. It is also very important, many times has been asked in your entrance examination as well as in your college examination. Okay. Now Wurtz reaction. So what is Wurtz reaction? Now in Wurtz reaction, alkyl halides react with metallic sodium in presence of dry ether to give you alkane, and mark that the alkane which is formed have twice the number of carbon atoms than that of the alkyl halides from which it is being formed. एथिरे कौन हुए ना alkyl halide कहाँ से react करिवो ना सोडियम metallic sodium सहित in presence of dry ether कौन दबो alkane दबो, and that alkane has twice number of carbon atoms than the alkyl halide from which it is being formed. तो मु लेखु चेटा R X, very simple reaction to remember. Don't try to mug up things. सबु जिनस घोषिया चेष्टा करनी. First you understand the chemical reaction, then you can write down in your own words. But first you must understand the reaction. So what I am telling, alkyl halide reacts with metallic sodium 2Na to give you alkane. To give you alkane. Mark here, what is the byproduct? Your byproduct is N2NaX. Mark the alkane which is formed here, it has twice the electron than the alkyl halide from which it is being formed. जो थ्रू तैयारी हेची ता अपेक्षा twice कौन रही कार्बन रही. So this is a convenient method for the preparation of alkanes having even number of carbon atoms. Mark करो, एटार limitation भी है ना. Only alkanes having even number of carbon atoms can be prepared by Wurtz method. So this is the example. एथरे कौन करा है जी ना मार्क करो. alkyl halide सोडियम दिया हला, इट पड़ेला कौन Na पड़ेला, you are getting alkane. एठी example दिया है कौन methyl halide reacts with sodium giving you ethane and 2 Na. Very easy to remember. Now if I want to prepare an alkane having odd number of carbon atoms, what will happen? Or if I will take two different kinds of alkyl halides with sodium metal, what will happen? Let us see the example. suppose I am taking, I want to prepare this, that is propane. So in order to prepare propane, I have to take kon namak padibo CH3 CH2 X halogen and 2Na plus X CH3, so that NaX will get removed and you will get propane. But mark that after starting the reaction, there is every possibility that there is presence of CH3 CH2 X अच्छे. तुम्हारा मन रखता जितेबाला आम रिएक्शन करूँ से गोटे मॉलिक्यूल थाए कि नो, देयर आर नंबर ऑफ क्रोड्स एंड क्रोड्स ऑफ मॉलिक्यूल्स in the container. So there is every possibility that ethyl halide, instead of reacting with methyl halide, can react with another ethyl halide. से निज सहित कौन करिवो react करिवो. React कले what is the product you are getting? You are getting actually butane. You are actually getting butane. Similarly, there is every possibility that methyl halide, instead of reacting with ethyl halide, will react with another ethyl halide, another methyl halide, forming ethane. So from this you mark that you want to prepare propane, but you are getting butane and ethane is side products. तुम side product भावे कौन पाउचो? Butane आउ propane पाउचो, sorry butane आउ ethane पाउचो. So whenever we try to prepare an alkane having odd number of carbon atoms from or by Wood's reaction, actually you will get a number of byproducts. And remember that the boiling point of these alkanes are very closer to one another. Hence, it will be very difficult for us to separate them once they are formed. So, it is not a very wise method to prepare for alkanes having odd number of carbon atoms. So what are the disadvantages of the Wood's reaction? Now, first one is that only alkanes having even number of carbon atoms can be prepared by Wood's reaction. We cannot prepare odd number of carbon containing alkanes. Now, the last one is methane cannot be prepared by Wood's reaction. कहीं तुम्हें देखिलो सब वाले दीटा combine है कि ही तुमको मिलुची रे जो product टा मिलुची. But methane तुम्हें minimum टा कोटा नहीं परियो. The minimum alkyl halide which you can take is actually methyl chloride. So methyl chloride will give you what? Now methyl chloride will give you ethane. So methane cannot be prepared by this method. And remember that I have already told you that the reaction is carried out in presence of dry ether. Why dry ether is taken? Because आम ये को metal use करचो. Now we are using the metal sodium, and you have already read it in the S block element that sodium react violently with water. Hence the solvent dry ether. There should not be any moisture, otherwise sodium will react with that moisture. Now remember that the Wood's reaction is a very important method for your conversion. जितेबाला तुम gradually पढ़ी जीवो in your class 12th, you will make organic compound. Suppose starting from A, you have to make another organic compound C. So for conversion type of reaction, when there is doubling of carbon atoms, Wood's reaction can be used there. This is called series ascending. Now the two mechanism has been proposed for Wood's reaction, and the one which is suitable more, that is free radical mechanism. Here what happens? Now it is assumed that first in the first step the sodium metal achi. Now the sodium metal gives this electron to this alkyl group forming alkyl free radical, alkyl free radical. मार्क करो सोडियम कौन कला निज इलेक्ट्रॉन टा आपको ट्रांसफर कला ये पड़ेला x माइनस थे कि ये Na प्लस हो गला. So in the second step we know that the free radicals are very unstable, highly reactive compounds. So in the second step another sodium metal, the second sodium metal it comes into the play and it also give rise its electron to the alkyl free radical. You know free radicals are neutral. बर्तमान से गोटे एक्स्ट्रा पाइला इलेक्ट्रॉन मीन इट बिकम्स नेगेटिवली चार्ज तो तुम कौन है R minus Na plus. In the third step this R minus will attack this. A co-type reaction, substitution type of reaction which we have already discussed in the previous chapter. So here R minus attack X सबले कौन delta negative, so इटा कौन हो delta positive. So this R minus attack this alkyl group forming your alkane and NX. This is the suitable mechanism or the preferred free radical mechanism which has been proposed for Ur's reaction. Now the drawbacks we have already discussed, that is methane cannot be prepared and alkyl groups, and the last drawback is alkyl group. Remember that whenever the alkyl group is bulky then it will undergo elimination type of reaction instead of your substitution type of reaction, giving you alkene. I have already told you in the previous classes that elimination and substitution they runs parallelly, सबले parallel chanti. Jodi bulky molecule nabo, they always preferred for undergoing elimination kind of reaction rather than substitution. Then the next one is reduction of alkyl halides. आमे पढ़ले एटा भी Ur's reaction को थ्रू तैयारी होची. The alkanes are being prepared from alkyl halides. Now there is another method, that is reduction of alkyl halide. Actually alkyl halides they have Rx. Now from Rx you are preparing RH. So instead of X we are replacing it with H. So which kind of reaction it is? This is reduction. तुमे जानी छो addition of और जितने hydrogen जदि आसीबो ताको को type रो कह जाय reduction, and these are some important reducing agents. Do remember these things. It will help you throughout the plus 2. So throughout the plus 2 एटा दरकार. So these are the reducing agent, that is zinc in presence of concentrated HCl, zinc in presence of sodium hydroxide, zinc copper couple and alcohol, lithium aluminum hydride, sodium borohydride, hydrogen iodide in presence of red phosphorus. We will discuss it one by one. So zinc in presence of acid, what happens? Zinc in presence of acid, what happens? Now here zinc loses 2 electron forming zinc 2 plus ion, and that electron is being gained by this alkyl halide forming jemti tomar Ur's reaction netla forming alkyl free radical. Then again it, you know that free radicals are very unstable compound, so it again gain 1 electron forming R minus. Now तुम्हें मीडियम रे कौन देचो ना मीडियम रे तुमरा अच्छी कौन देचो एसिड देचो तो कौन हला ना RH. So in general you are getting an alkane. Now in case of when you take zinc and sodium hydroxide, what happens? Zinc react with sodium hydroxide, producing sodium zincate and nascent hydrogen. This hydrogen actually reacts with your alkyl halides forming alkane and कौन HX. तो मन रहा जितेबाला जिंक टा तुम क्या सहित नौच ना सोडियम हाइड्रोक्साइड रे. This is a very good reducing agent. Why it is a very good reducing agent? Because it produces nascent hydrogen. Nascent hydrogen means hydrogen which is very reactive in nature, that is called nascent hydrogen. Atomic form रहते हो बहुत reactive है तो. So that hydrogen actually participate with our alkyl halide forming your alkane and HX. Now reduction with chemical reagents like lithium aluminum hydrides, these are called organometallic compounds. Term ta suno धीरे धीरे ये term बहुत use करिवो. Organometallic compounds are those in which there is direct bonding between carbon and a metal. So in lithium aluminum hydride or sodium borohydride, so these are what happens now in case of your in case of lithium aluminum hydride, your structure is like this. Lithium plus aluminum H, H, H and H. There is another H. This total is negative. So there is a transfer of hydrogen containing negative charge. H minus है कहाँ को attack करिवो ना H minus है कि alkyl halide रे mark करो. In alkyl halide R is always positive and X is negative. Hence in alkyl halide the H minus will attack the what? The carbon. Carbon टाकू attack करिवो. Attack करी कौन करिवो ना तुमको alkane दबो plus X minus दबो. Remember that lithium aluminum hydride is one of the strongest reducing agent. Organic रे तुमे जितने reducing agent पढ़िवो, lithium aluminum hydride is one of the strongest reducing agent and it can reduce anything. So remember that lithium aluminum hydride will readily reduce primary and secondary, but in case of tertiary alkyl halide, actually I have already told you that bulky molecules they prefer to undergo elimination reaction rather than substitution reaction. So in tertiary alkyl halide you will find alkene as the major product. Sodium borohydride, it is a very good reducing agent, but it is comparatively that is softer than lithium aluminum hydride. So sodium borohydride can convert secondary and tertiary alkyl halide, but it is unable to convert primary alkyl halide to alkane. Now reduction with red phosphorus and HI. Mark that your red phosphorus and HI, it is a very good reducing agent. Starting from acid to your alkyl halide, it can reduce anything. So red phosphorus HI is a very good reducing agent. What happens? Now here alkyl halide reacts with HI forming your alkane and iodine. Mark karo. Here actually HI is taking part in the reaction. So what is the function of red phosphorus? The function of the red phosphorus is to take away this iodine as soon as it is formed. Why? Because this is a reversible reaction. Jodi se iodine taku no nabo, then the iodine will again react with this alkane, forming your, giving you the alkyl halide again. So tumar darkar kon? You required alkane. Hence red phosphorus is used to take away this iodine molecule as soon as it is being formed. And remember that starting from your carboxylic acid to alcohol to aldehyde ketone, you can reduce anything with the help of red phosphorus and HI. So from carboxylic acid, so alkenes can be prepared from carboxylic acid by two methods, that is decarboxylation, and another method is Cole's electrolytic method. Mark that the term decarboxylation, whenever you will learn this term means removal of carbon dioxide, decarboxylation. Whenever carbon dioxide is removed from any molecule, that is called decarboxylation. Then, so what happens in decarboxylation? In this process, the carboxylic acid is heated. The carboxylic acid is heated with soda lime. Caustic soda, what is the formula for caustic soda? Sodium hydroxide. Calcium oxide is called quicklime. So quicklime plus caustic soda. ए दुटा को मिसिक आसला ना कोन सोडा लाइम. Soda lime is a mixture of sodium hydroxide and calcium oxide. So, if you take carboxylic acid and heat it with the help of soda lime in presence of soda lime and soda lime and calcium oxide, you will get an alkane molecule having less number of carbon atoms than the acid. Mark that in this reaction the alkane is formed which is having one carbon less than the carboxylic acid from which it is being formed. So, mark that students, it is very important. Why? Because in the conversion reaction you will require this reaction. Jetebale tumara series ta kamebar thibo, carbon amount kamebar thibo, this is a very good method to reduce the number of carbon atoms. So, mark what is happening here. Now, sodium salt of carboxylic acid. Mark karo tume nei shakono. You are taking carboxylic acid. Now, carboxylic acid will react with sodium hydroxide forming sodium carboxylate. Instead of using carboxylic acid, actually we are converting it into its salt, that is RCOO minus Na plus. Then it will react with sodium hydroxide producing alkane and sodium carbonate. So, what is the function of sodium hydroxide? Now, the function of the sodium hydroxide is to provide a basic medium. It is it is providing a basic medium so that the ion RCOO minus, it will not again convert back to acid. Amar darkar kono carboxylate ion. So, basic medium rahile the carboxylate ion cannot get converted to the acid again. That is the function of the sodium hydroxide. The second function is it can't release it release by carbon dioxide. So, sodium hydroxide reacts with carbon dioxide forming your sodium carbonate. So, these are the two functions of sodium hydroxide. Now, the second question arises, what is the function of calcium oxide? Now, the calcium oxide helps to increase the rate of the calcium oxide help us to increase the rate of the temperature, higher temperature. High temperature, तुम जानते हो sodium hydroxide पे high temperature दरकार. So, calcium hydroxide help us to increase the and ensure this higher temperature to complete the decarboxylation process. Okay, this is the function of the calcium oxide. And another function is calcium oxide is a hygroscopic compound. What are hygroscopic compound? तो मार्क करथिबो तम बैग रे सब छोटो छोटो बैग हरिका करथिबो छोटो छोटो पाउच टाइप रो पड़थिबो कॉस्टली बैग हरिका रे. That is an example of hygroscopic compound. They absorb your moisture from the surroundings. ସେମାନେ सबले कोन करंती moisture सब absorb करंती. Calcium oxide is a very good hygroscopic material, hence it absorbs the moisture which is present in the reaction. Remember that in the laboratory methane is prepared, in the lab methane is prepared by the decarboxylation of sodium acetate, lab method of preparation. Now, with this I am concluding today's lesson. In the next class we are going to discuss other methods of preparation of alkanes and its chemical reaction. Thank you. Have a good day.